Our universe might be a single sentence in a story too vast to read. We are about to journey through 30 incredible theories that reveal the hidden timelines potentially woven into the fabric of reality. By the end, you will possess a new framework for understanding everything from the Big Bang to your own place in the cosmos. We will explore if the flow of time is an illusion and whether our past is truly set in stone. What single mystery about time keeps you up at night? The first theory shatters the idea of a single cosmic beginning. Cosmic inflation, the brief period of unimaginable expansion after the Big Bang, might not have been a one-time event. Instead, it could be an eternal, endless process. Picture a vast, bubbling pot of water that never stops boiling. Each bubble that forms and rises to the surface is a brand new universe, spontaneously budding off from the inflating background. This is the theory of eternal inflation. In this breathtaking picture, our entire observable cosmos, with all its hundreds of billions of galaxies, is just one single bubble in an infinite cosmic froth. This concept, deeply rooted in the work of physicist Alan Guth, suggests that the vacuum of space possesses an intrinsic energy that drives this never-ending expansion. Each new bubble universe cools and stabilizes, but it does so with a random, unique set of physical laws and constants. In one bubble, gravity might be crushingly strong, forming instant black holes. In another, the nuclear forces might be too weak to ever form atoms. Our universe, with its perfect balance for life, is simply one lucky roll of the dice in a cosmic casino with infinite tables. This means there is no single timeline for reality. Each bubble has its own beginning, its own history, and its own potentially lonely end, completely disconnected from all the others. We are living inside one fragile paragraph of an infinite book where every page tells a different story. Yet even within our own single bubble of reality, the timeline might not be a straight line. It could be a constantly forking path. The second theory takes the strange rules of the quantum world and applies them to the entire cosmos. This is the many worlds interpretation of quantum mechanics proposed by physicist Hugh Everett. It suggests that every single possible outcome of every single quantum event actually happens. Think of the famous thought experiment, Schrödinger's cat. A cat is placed in a box with a radioactive atom. If the atom decays, it triggers a mechanism that releases poison. According to quantum rules, until someone opens the box and looks, the atom is in a blurred state of both decayed and not decayed. This would mean the cat is both alive and dead at the same time, a bizarre superposition. The classic view is that the act of looking forces the system to choose one state. But Everett's radical idea is that it never chooses. Instead, the very moment of observation causes the entire universe to split in two. In one brand new, equally real branch of reality, you open the box and find a living cat meowing for its dinner. In another, completely separate branch, you open the box to a tragic outcome. Both events are real, both timelines are actual. They simply decouple from each other and evolve independently from that point forward. Now extend this idea beyond a single cat in a box. Every quantum particle's random flicker, every subatomic dice roll, creates a new fork in the road. Every time an electron could go left or right, the universe splits, and it goes both ways in two new worlds. This process is happening constantly at every moment for every particle. The result is not one history, but an ever-growing, infinite tree of parallel realities. In one branch of that tree, you are listening to this script. In another, you decided to click on a different video entirely. In a far-flung branch, dinosaurs might never have gone extinct. This theory weaves an almost unimaginable tapestry of existence, where every possibility is explored, every story is told, and our singular experience is just one thread in an infinite, branching web of time. But what if our universe is not a unique bubble or a branching path, but a single heartbeat in an eternal cosmic rhythm. This is the third theory, the cyclic model, often called the Big Bounce. It proposes that the Big Bang was not the absolute beginning of everything. Instead, it was simply the latest rebirth in an endless, timeless cycle of universal death and renewal. Picture a cosmic lung breathing in and out for all of eternity. Each full breath is one complete eon or cycle of the universe. It begins with a violent, rapid expansion from a hot, dense state, which is the Big Bang we study. The universe then evolves for billions of years, forming galaxies, stars, and planets. But eventually, the outward push of the initial expansion weakens, and the relentless pull of gravity takes over. All matter and energy scattered across the vastness of space are drawn back together. Galaxies rush toward each other, stars collide, and everything is compressed into an unimaginably hot and dense singularity. This is the Big Crunch, the end of the cycle. Yet, in this model, the crunch is not a final end. It is a transformation. The incredible energy and density of the crunch trigger a rebound, a new Big Bang, and the cycle begins again. A new universe is born from the ashes of the old. This introduces a profound hidden timeline, a looping history where each cycle might be subtly different from the last. The physical constants, the very rules of reality like the strength of gravity or the mass of an electron, could be randomly reshuffled with each new bounce. In one cycle, the constants might be perfect for life to flourish. In the next, they could be utterly hostile, creating a dark, empty universe. Our existence, then, is not the result of a single, lucky roll of the dice, but one winning ticket in an endless lottery that has been running forever. We are living in just one chapter of a book that has been written, erased, and rewritten an infinite number of times. The very fabric of space and time we inhabit could be an astonishingly convincing illusion. Our perception of a solid, three-dimensional world, complete with a flowing timeline, might be nothing more than a grand projection like a cosmic hologram. This is the fourth theory, the holographic principle. It proposes that all the information that makes up our universe, every galaxy, every person, and every moment in history, is actually encoded on a distant, two-dimensional surface that surrounds us at the cosmic horizon. Think of watching a breathtakingly realistic three-dimensional movie. The entire immersive experience, with its depth and movement, is contained on a flat, two-dimensional screen. In a similar, though far more fundamental way, our reality might be a cinematic display projected from the boundary of the universe. What we experience as the past, present, and future could all be permanently etched onto this cosmic film, existing simultaneously from a higher dimensional perspective. Your birth, your life, and every event yet to come might already be written there, like individual frames on a reel. This does not mean our lives are predetermined in a fatalistic sense, but rather that the entire timeline is a fixed structure we are simply moving through. The flow of time, that undeniable feeling of a present moment slipping into the past, would then be a powerful, emergent property generated by our consciousness as it interacts with this encoded data. We are not watching the movie, we are living inside it, experiencing it one frame at a time, completely unaware that the entire story is already complete. Einstein's theory of relativity paints a picture of reality far stranger than our everyday experience suggests. It proposes that the past, present, and future are not a sequence of events, but all exist simultaneously. This is the block universe theory, a model where time is just another dimension, much like length, width, and height. In this four-dimensional block of space-time, every event that has ever happened or ever will happen is permanently fixed in its location. Your first breath, the fall of ancient Rome, and the death of the last star are all equally real, all just sitting at different coordinates in this vast, unchanging structure. The feeling that time is flowing, that the future is open and the past is gone, is a powerful illusion generated by our conscious minds. We are like travelers on a long, winding road, experiencing the journey one step at a time. But from a vantage point outside the block, the entire road exists at once, from its beginning to its very end. This means your life is not a story being written, but a story that is already completely written, its entire timeline laid out in the grand architecture of the cosmos. The you that is reading this, the you as a child, and the you of decades from now all exist with the same solid reality, forever held in the eternal now of the spacetime block. Your entire life, from your earliest memory to this very moment, might be nothing more than a line of code in a supercomputer of unimaginable power. This is the sixth theory, the simulation hypothesis, a concept that suggests our universe, with all its history and hidden timelines, is an artificial construct. The argument, famously formalized by philosopher Nick Bostrom, presents a compelling trilemma, a set of three possibilities, at least one of which must be true. First, almost every civilization that reaches our level of technological maturity goes extinct before it can create realistic simulations of its own history. Second, if a civilization does advance to that godlike stage, it has exactly zero interest in running such ancestor simulations. Or third, and this is the profound part, we are almost certainly living inside a simulation right now. The logic is startlingly simple. If even one advanced civilization ever chooses to create highly detailed simulations of its past, and if those simulated beings within the program eventually become advanced enough to create their own nested simulations, then the number of simulated universes would quickly dwarf the one original base reality. The odds, therefore, heavily favor us being one of the countless simulations rather than the singular, original beings. This reframes every hidden timeline we have discussed. The branching paths of the many worlds interpretation could simply be different instances of the program running in parallel. The cyclical big bounce might be a recurring loop written into the core code. Even the block universe, where all of time exists at once, could be explained as the entire dataset being permanently stored on a cosmic hard drive. If this is true, then the laws of physics are not fundamental truths, but merely the rules of the simulation, the algorithms that govern our reality. This leads to a fascinating search for potential glitches in the matrix, tiny errors or shortcuts a programmer might have taken. Some scientists have seriously proposed that we might find evidence in the very fabric of space, perhaps in the behavior of high-energy cosmic rays or in strange, unexplained quantizations in the universe's energy. Finding such an anomaly would be like discovering a pixel in an otherwise flawless virtual world, a single clue that the timeline we experience is not a fundamental reality, but a carefully crafted illusion running on something far greater and more mysterious. While a simulated reality is one way to explain our existence, another theory suggests the evidence for a hidden timeline is written directly in the oldest light we can see. Roger Penrose's conformal cyclic cosmology proposes an endless cycle of universes, but this cycle is far gentler than the violent crush of a big bounce. In this model, our universe does not end in a catastrophic collapse. Instead, it simply expands forever, growing colder, darker, and more empty as all matter eventually decays and black holes evaporate. After trillions upon trillions of years, the universe reaches a state of maximum entropy, a featureless sea of low-energy radiation where time itself loses all meaning. There are no stars, no planets, and no events to mark the passage of time. In this strange, smooth state, the universe becomes mathematically identical to the hot, dense, and equally smooth state of a new Big Bang. The end of one cosmic story seamlessly becomes the beginning of the next. Penrose calls each of these infinite cycles an eon. Our universe is just one eon in an endless, timeless sequence. The transition between eons is not a violent rebirth, but a quiet, geometric reset where the scale of the universe changes but the fundamental geometry remains. This means our Big Bang was not a true beginning, but the conformal continuation of a previous eon's distant future. The most breathtaking part of this theory is the potential for evidence. If our universe was born from the death of a previous one, there might be faint scars or echoes left behind from that prior timeline. Penrose and his colleagues believe they have found these echoes. They are searching for specific patterns in the cosmic microwave background, the afterglow of our own Big Bang. These patterns, known as Hawking points, are hypothesized to be rings of slightly higher temperature. They are thought to be the final, imprinted bursts of energy from supermassive black holes that evaporated at the end of the previous eon. If these points are confirmed, they would be more than just cosmic curiosities. They would be our first real window into a universe that existed before our own, a direct glimpse into a timeline that ended in silence only to give birth to everything we know. We could be looking at the ghostly remains of ancient galaxies and alien civilizations, their final signatures permanently etched into the dawn of our own world. The ghost of a previous universe imprinted on our cosmic background is not the only clue that time is not what it seems. Our relentless forward march through the days and years might be the most convincing illusion of all. This eighth theory confronts a radical idea that time itself is not a fundamental part of the cosmos. It may be an emergent property, a collective effect that arises from a more basic, timeless layer of reality, much like the wetness of water emerges from the collective behavior of countless individual molecules that are not themselves wet. Some of the most promising theories of quantum gravity, attempts to unite Einstein's relativity with the quantum world, point toward this startling conclusion. In their raw mathematical form, equations describing the fundamental building blocks of the universe often lack a time variable altogether. The deep code of reality appears to be written in a realm where before and after have no meaning. So where does our powerful, unshakable sense of time come from? One compelling answer lies in a strange quantum connection called entanglement. When two particles become entangled, they lose their individual identities and behave as a single system, no matter how far apart they are separated. A change to one instantly affects the other, a phenomenon Einstein famously called spooky action at a distance. This intricate web of quantum connections, linking every particle in the universe, may be what creates the emergent structure we experience as the flow of time. The continuous process of these particles interacting, correlating, and becoming entangled with one another generates a kind of cosmic order, a record of what is connected to what. Our conscious journey from one moment to the next could be our perception of this ever-increasing complexity of quantum relationships. Imagine a vast, unmoving ocean, completely still and timeless. Our experience of time is like watching a wave travel across its surface. The wave has a clear direction and momentum, but the ocean itself does not flow. The wave is an emergent property of the water's deeper, motionless state. In this view, your memory of the past is not a record of a moment that has vanished. It is a specific pattern of entanglement in your brain, a frozen relationship between particles that stores information. The feeling that the future is open and uncertain reflects the fact that the universal web of entanglement has not yet formed those specific connections. This implies our linear timeline from the Big Bang to the distant future is a grand macroscopic illusion projected from a silent, timeless foundation. The past, present, and future are all equally real in the sense that the entire network of quantum connections exists, but we, as complex structures within that network, can only perceive it sequentially, one entangled relationship at a time. The uncanny precision of our universe's settings is enough to make anyone pause. Why do the fundamental forces have exactly the strength they do, allowing for stable atoms, long-lived stars, and the complex chemistry of life? If the force of gravity were even slightly stronger, the universe would have collapsed back on itself in a fiery crunch shortly after the Big Bang. If it were slightly weaker, matter would have flown apart too quickly to ever coalesce into galaxies and stars. This perfect balance is not limited to gravity. The nuclear forces that bind atoms, the mass of the electron, even the amount of dark energy accelerating cosmic expansion, all appear to be exquisitely fine-tuned. This observation leads us to the ninth theory, the anthropic principle. In its most compelling form, this principle suggests a startling explanation for this cosmic luck. It posits that we should not be surprised to find ourselves in a universe capable of supporting life, because in a universe that was not fine-tuned, we would not exist to observe it in the first place. But how can this be anything more than a philosophical statement? The answer lies in the existence of a multiverse. If eternal inflation or the many worlds interpretation is correct, then there are not just a few, but an infinite number of separate universes. In this vast cosmic landscape, each universe is born with a random, unique set of physical constants and laws. The overwhelming majority of these universes are stillborn or barren. In one, gravity is so intense that only black holes form instantly. In another, the electromagnetic force is too weak to hold electrons in orbit around a nucleus, so atoms never come into being. These are silent, dark timelines where the concept of life is meaningless. Our universe, then, is not a miracle of design. It is simply the one lottery ticket out of an infinite number printed that happened to have all the right numbers. We are not special, we are just lucky. We exist in the one narrow band of reality where the constants allow for galaxies, planets, and conscious beings to ponder their own existence. This means that for every timeline we experience with its stars and its life, there are countless other hidden timelines where the physics is so alien that our reality would seem like magic. The fine-tuning we observe is not a clue pointing to a creator, but the inevitable selection bias of finding ourselves in the only kind of place we could possibly inhabit. Our entire cosmic history is just one possible story in a library containing every story that could ever be written, and an infinite number more that are nothing but gibberish. The idea that time might actively prevent paradoxes sounds like science fiction, yet it is a serious proposal from the heart of theoretical physics. The Novikov self-consistency principle, formulated by Russian physicist Igor Novikov, offers a radical solution to the headaches of time travel. It asserts that if time travel to the past is possible, then the universe operates under a single, unbreakable rule. Any actions taken by a time traveler were always a part of history. There can be no changes, no alternate branches, and no grandfather paradoxes, because the timeline is a single, self-correcting loop of consistent events. Imagine someone travels back to Elizabethan England with the complete works of Shakespeare, intending to give the plays to the young bard. In a typical time travel story, this would create a glaring paradox. Where did the plays truly come from? But under Novikov's principle, this scenario could not create a new timeline. Instead, it always happened. The plays you possess, the very ones you brought from the future, are the ones Shakespeare himself originally wrote. He did not create them from nothing, he merely transcribed the works you handed him. Our recorded history, with Shakespeare as the celebrated author, is the only consistent version of events, and it already includes the time traveler's hidden involvement. The timeline seamlessly conceals its own manipulation. This principle suggests a universe that is ruthlessly efficient at protecting its own past, weaving the actions of any potential time travelers so perfectly into the fabric of history that their interference becomes invisible. Your free will to alter events would be an illusion, constrained by the absolute requirement that you do nothing to disrupt the sequence of cause and effect that led to your own journey in the first place. The past is not a fragile thing to be broken, but a fortress of logical consistency, where every attempt to change it was always a part of its unalterable story. The branching of reality may not be happening out in the cosmos, but inside your own mind. the 11th theory, the many minds interpretation, offers a startling twist on the idea of parallel worlds. While Hugh Everett's many worlds theory suggests the entire universe physically splits with every quantum event, this variation proposes a different stage for the drama. The external universe remains singular and unchanging, a vast static block of spacetime. What splits is not the world but your conscious perception of it. Every time you face a quantum choice or even a simple decision, your awareness fractures into multiple, separate streams of consciousness. Each stream experiences one of the possible outcomes, completely isolated from the others. You are not hopping between timelines, you are constantly multiplying within a single, objective reality. Picture a single, unchanging movie reel containing every possible scene and ending. The many worlds view says the projector creates a new screen for every version. The many minds view says there is only one projector and one screen, but every member of the audience is wearing a different set of glasses, each filtering the film to show only one specific, consistent storyline. At this very moment, a version of your mind is listening to this script. Another version, in that same room, in that same universe, decided to stop listening moments ago and is now checking a message on their phone. Both experiences are equally real to the minds having them, yet they are unfolding within the same physical space, completely unaware of each other. This solves a deep philosophical puzzle about identity. You are not a single, continuous self, but a constantly branching tree of conscious moments. The you of 5 minutes ago has already split into countless versions of the you that exists now, each one convinced their reality is the only one. This means the hidden timeline is not woven into the fabric of the cosmos, but into the very fabric of your own subjective experience, a silent, infinite fracturing of awareness within a single, silent universe. The unsettling truth is that you might have popped into existence just a moment ago. This is the startling premise of the Boltzmann brain paradox, a thought experiment that turns our confidence in reality inside out. It emerges from the deep laws of thermodynamics, which govern the inevitable slide of the universe from order toward disorder. In any isolated system, random fluctuations can and do occur, momentarily creating pockets of order from the surrounding chaos. In a vast, eternal, and ultimately empty cosmos, the most likely fluctuation is not the spontaneous creation of an entire, structured universe lasting billions of years. It is the fleeting, random assembly of a single, self-aware brain, complete with a full set of fabricated memories and a convincing sensory experience of a world that does not actually exist. According to this logic, a lone, disembodied brain floating in the void, hallucinating an entire life and cosmos, is statistically more probable than the genuine 13.8 billion year history we take for granted. Your memory of waking up this morning, the sound of a loved one's voice, the very screen you are looking at right now, could all be an incredibly detailed but utterly false fabrication. You are not a product of a long cosmic timeline, but a momentary accident in an endless, timeless sea of nothingness. This paradox forces a brutal reevaluation of everything. The entire sweep of human history, the rise and fall of dinosaurs, the birth of stars, all of it could be nothing more than an elaborate backstory conjured for a single, conscious instant that will vanish as quickly as it appeared. The hidden timeline you believe you inhabit is not a record of the past, but a phantom script written for a transient audience of one. So why does the universe feel so real and consistent? This is the paradox's terrifying core. The universe we observe is impossibly, beautifully ordered, a state of such low probability that its existence seems to defy the very statistical reasoning that gave rise to the theory. Resolving this paradox is one of the great challenges of modern cosmology, pushing us to question whether our most fundamental assumptions about time, memory, and existence itself are nothing but a grand and fleeting illusion. A black hole's grip is so powerful that nothing, not even light, can escape its event horizon. But what if that one-way street has an exit ramp in another reality? The 13th theory introduces a breathtaking counterpart, the white hole. If a black hole is a cosmic drain from which nothing returns, a white hole is its theoretical opposite, a gushing fountain of matter and energy that nothing can ever enter. It is a place of pure, relentless expulsion, a one-way door out of a hidden dimension. Now take this strange idea and stretch it to the very beginning of everything. What if the Big Bang itself was not a singular, spontaneous event, but the violent, radiant eruption of a white hole? In this radical cosmology, our entire universe, from its first fiery moment to its present vast expanse, is simply the interior of a black hole residing in a much larger parent universe. When a massive star collapses in that higher reality, it forms a singularity, a point of infinite density. But instead of being a final destination, that singularity becomes a white hole in a new, baby universe, pouring forth all the energy and matter that will form galaxies, stars, and planets. Our cosmic history is not the main story. It is a self-contained timeline hidden within the event horizon of a colossal black hole in a world we can never see. Every star that dies here, collapsing into a black hole of its own, might be performing the same cosmic magic. Each one could be the seed for a brand new universe, bubbling into existence with its own unique laws, its own hidden timeline, and perhaps its own civilizations gazing up at their own night sky, completely unaware they are living inside the corpse of a star from a universe above. This vision creates an infinite fractal cascade of realities, a cosmic matryoshka doll of embedded timelines, where every black hole is a potential gateway to a whole new creation. Our own timeline, the very history we take for granted, might be a carefully constructed fiction. The 14th theory plunges us into a historical conspiracy of epic proportions. The phantom time hypothesis proposes that a 300-year chunk of the early Middle Ages, from the year 614 to 911, was completely invented. According to this radical idea, we are not living in the year 2024, but somewhere closer to the year 1724, because 3 entire centuries of the Dark Ages are a ghost story woven into our calendars. The architect of this theory, a German historian named Heribert Illig, argued that the historical record from this period is suspiciously thin, filled with recycled narratives and a puzzling lack of verifiable archaeological evidence. He points to the reign of the Holy Roman Emperor Otto III and Pope Sylvester II, suggesting they conspired to alter the calendar, perhaps to place Otto's reign symbolically in the year 1000. To achieve this, they would have had to fabricate 300 years of history out of whole cloth. Imagine the sheer scale of such a deception. Every king's chronicle, every religious text, every record of battles and plagues from that era would be an elaborate forgery, a phantom narrative inserted into the timeline. Proponents of this idea also look to the skies, noting inconsistencies in astronomical events like eclipses that, when recalculated, seem to align better if those 3 phantom centuries are simply removed. This would mean that Charlemagne, one of history's most celebrated figures, might be a largely fictional character, a composite legend created to fill the empty years. The implications are staggering. It would compress our entire understanding of the past, meaning the Roman Empire fell much later than we thought, and the Renaissance began almost immediately afterward. The 1,000-year gap of the Dark Ages would vanish, revealing a direct and uninterrupted cultural thread. Of course, the vast majority of historians and scientists reject this hypothesis, citing robust dendrochronological evidence from tree rings and ice core samples that clearly record annual layers spanning the entire period in question. Yet the theory persists as a powerful reminder of how fragile our connection to the past truly is. It forces us to confront a haunting possibility. The timeline we study, the foundation upon which we build our identity, could be a palace built on a void, a story where the most hidden chapters are the ones that were never written at all. The fragility of our historical record is one thing, but what if time's own structure is far more malleable than we ever dreamed? We arrive now at the 15th theory, a concept so strange it seems to defy the most fundamental laws of physics, the time crystal. In our everyday world, objects in their resting state are motionless. A perfect diamond sitting in a vacuum at absolute zero should be completely still, its atoms locked in place. Yet time crystals are a new phase of matter that shatters this expectation. They are systems that, even in their ground state, their state of lowest possible energy, are in perpetual, repeating motion. Think of a clock that ticks forever without any batteries or a spring to wind it. It is not consuming energy, nor is it losing energy to friction. It is simply ticking forever, driven by a bizarre loophole in the quantum laws of the universe. This is not science fiction. Time crystals have been created in laboratories using chains of ions or dense clouds of atoms, carefully manipulated to enter this exotic state. Their secret lies in breaking what physicists call time translation symmetry. In a normal, periodic system like a swinging pendulum, the laws of physics are the same at every moment in time. The swing is identical whether you observe it now or 5 minutes from now. A time crystal is different. Its behavior, its very structure, repeats at a regular interval, but the system does not look the same at all times. It has a preferred tick, a rhythm that the rest of the universe does not share, as if it is marching to the beat of its own hidden drum. This discovery forces us to ask a profound question. Could time itself have a crystalline structure on some fundamental level? Is the smooth, flowing river of time we experience actually built from countless, tiny, repeating loops at the quantum scale? The implications are staggering. If we can learn to control and scale up time crystals, they might one day form the heart of ultra-powerful quantum computers, their stable, periodic rhythms protecting fragile calculations from outside interference. But even more fantastically, they could be the key to understanding or even creating stable temporal structures. A sufficiently complex time crystal might act as a scaffold for a self-sustaining time loop, a closed circuit in time where cause and effect circle back on themselves eternally. This would not be a machine for traveling to the past, but a pocket of reality where a specific sequence of events repeats over and over, forever locked in a moment outside the main flow of our timeline. It offers a tantalizing glimpse that other temporal dimensions, or at least other temporal structures, might not just be mathematical curiosities, but physical realities waiting to be engineered. Our universe might be a single membrane floating in a higher dimensional void. The ekpyrotic universe model reimagines the cosmos not as a solitary bubble, but as a vast three-dimensional sheet or brain drifting through a grander space called the bulk. In this higher dimensional arena, our brain is not alone. Other brains, other entire universes, float in parallel, separated by a microscopic gap. The Big Bang in this radical picture was not an explosion from a single point. It was a cataclysmic collision. Our brain smashed into a neighboring one in a violent, universe-spanning impact. The immense kinetic energy of that crash was instantly converted into the searing heat and dense matter that filled our newborn cosmos. This was the moment our timeline began, but the story does not end there. The force of the collision sends the brains flying apart, and our universe expands and cools just as we observe. Yet the subtle pull of gravity across the bulk slowly draws the two brains back together over trillions of years. They approach for another impact, another Big Bang, and another cycle of creation. Our cosmic history is not a one-act play, but a single verse in an endless cosmic dance of attraction, collision, and rebirth. Each collision completely resets the universal timeline, erasing the old and beginning the new, though the fundamental laws of physics may remain constant from cycle to cycle. This means the entirety of our past, from the first stars to the rise of civilization, is just the most recent iteration in an infinite series of universal lifetimes. We are living in the aftermath of one collision, awaiting the next, our existence a brief, bright flash between two timeless, rhythmic embraces in the dark. The linear flow of time from cause to effect feels like the most unbreakable rule of existence, but at the quantum level, this bedrock principle begins to crumble. The 17th theory, retrocausality, proposes a reality where the future can reach back and touch the past, where effects can precede their causes. This is not mere philosophy, it is a possibility forced upon us by some of the strangest experiments ever conducted. Consider the delayed choice quantum eraser. In this test, a single particle of light, a photon, is shot toward a screen through a special crystal that splits its path. The photon can take two possible routes, behaving like a wave that travels both paths simultaneously. Further along, detectors are placed to catch it. The bizarre result is that a decision made in the present about how to observe this photon seems to rewrite its history. If a scientist chooses to measure which path the photon took, it will have behaved like a single particle all along. But if the scientist chooses to erase that path information, allowing the photon to remain in a state of quantum uncertainty, records show it will have behaved like a wave that interfered with itself. The present observation appears to dictate what the particle did in the past. It is as if the photon, at the moment of its creation, already knew how it would be observed billions of a second later. The future outcome reaches back in time and locks in the particle's behavior. This shatters our everyday logic. If these quantum effects scale up, it implies that the future might not be an open, uncertain landscape, but a fixed destination that is already collaborating with the present to ensure its own arrival. Your choices today would not be creating a new future, but fulfilling a timeline that has, in a sense, already been written. The entire cosmic story, from the Big Bang to the last star, could be a single, self-consistent loop where the ending gently guides the beginning into place. A surprising number of people remember a world where Nelson Mandela died in prison during the 1980s. They recall news reports and a global outpouring of grief. Yet in our recorded timeline, he was released, became president of South Africa, and passed away in 2013. This collective false memory is so widespread it gave its name to an entire phenomenon. The Mandela effect describes these moments where large groups of people share a specific, detailed memory of something that never happened. The classic examples are everywhere. Many are convinced the children's book series was spelled Berenstain Bears with an E, not Berenstain with an A. In the film Star Wars, Darth Vader's iconic line is universally misremembered as Luke, "I am your father," when the actual line is, "No, I am your father." For most scientists and psychologists, the explanation is straightforward. It is a simple failure of memory, a trick of the mind where our brains, which are pattern-matching machines, fill in gaps with the most likely or familiar information. We expect Stein to be Stein because that is a more common surname ending. We expect the dramatic line to be more personal and direct. Our memories are not perfect recordings but reconstructions, and they are easily influenced by suggestion and social reinforcement. But what if the truth is far stranger? A fringe theory suggests these are not errors at all, but residual echoes from alternate timelines. In the vast, branching multiverse of the many worlds interpretation, perhaps these branches are not always perfectly isolated. Could there be moments of quantum leakage where information or even entire events from a neighboring timeline briefly superimpose onto our own? In one reality, perhaps Nelson Mandela did die in the 1980s, and the collective memory of that tragic event has bled through the dimensional barrier, leaving a ghostly imprint in the minds of millions here. The Berenstain Bears with an E may be the correct spelling in a parallel universe very close to our own, a universe whose history diverged only on the point of a single letter in a family name. This theory posits that when we experience the Mandela effect, we are not misremembering. We are actually remembering correctly, but we are accessing a memory from a different version of our own life, a life that unfolded in a timeline that has since been overwritten or merged with our current one. The unsettling chill you feel when you discover one of these discrepancies is not the shock of being wrong, but the uncanny sensation of reality itself being wrong, a fleeting glimpse of the infinite, branching tapestry of existence where every possible detail is real somewhere. While there is no concrete scientific evidence for this interpretation, it transforms a pop culture curiosity into a profound philosophical question. It asks us to consider whether our most trusted anchor, our own memory, might occasionally be a compass pointing not to our past but to someone else's. Stephen Hawking once proposed a cosmic rule so absolute it functions as a universal security system. His chronology protection conjecture insists the laws of physics will not permit time travel to the past. It is not that the universe is incapable of creating the necessary conditions, but rather that it actively prevents them. The timeline, in this view, is not just consistent, it is fiercely guarded. Any attempt to build a machine that could send you backward would be thwarted by nature itself. Imagine a would-be time traveler has constructed a theoretical device, perhaps one that spins a cosmic string at near light speed to warp spacetime into a closed loop. Just as the machine is powered up, about to open a gateway to yesterday, an unstoppable quantum fluctuation occurs. A random energy spike materializes from the vacuum of space, overloading the system's core and causing it to fail catastrophically. Or perhaps immense gravitational tidal forces, generated by the very warping of space, tear the machine apart at the atomic level before the loop can be completed. The universe, it seems, possesses a kind of immune response to paradox. Hawking suggested this protection might come from the behavior of quantum fields in the severely curved spacetime around a potential time machine. Virtual particles constantly flashing in and out of existence could be amplified to infinite energy as they try to travel back and interact with their own past versions. This runaway feedback would destroy the time travel corridor, effectively slamming the door shut before anyone could step through. It is a fail-safe woven into the quantum fabric of reality, ensuring that cause always precedes effect. The past remains a sealed book we can read but never rewrite. This conjecture offers a profound and almost comforting conclusion. Our history is safe not by accident but by fundamental law. The single, consistent timeline we experience is the only one possible, rigorously defended against the chaos of paradox by the universe's own immutable rules. The fabric of reality might be a cosmic mind learning and evolving. This 20th theory proposes that the universe itself is a vast, dynamic neural network. Each node in this network is not a star or a galaxy, but a fundamental unit of spacetime, a tiny grain of existence. The connections between these nodes, their synaptic weights, are what we experience as the laws of physics. Gravity, electromagnetism, even the flow of time, are not fundamental truths written on a cosmic tablet. They are emergent behaviors, patterns that arise from the complex, learning dynamics of this network as it processes information. What we call the passage of time is simply the network adjusting its connections, learning from its own state, and updating its internal model of reality. Each tick of the cosmic clock is one training cycle, one forward pass through the data of existence. In this view, the Big Bang was not an explosion, but the initialization of the network's parameters. The subsequent evolution of the cosmos, the formation of the first elements, the birth of stars, and the rise of life, represents the network's training process. It is learning to become more stable, more complex, and perhaps more self-aware. An epoch, a term from machine learning for a complete pass through a dataset, could correspond to a phase of cosmic history. The transition from a hot, dense plasma to a transparent universe filled with galaxies might have been the universe's first major epoch, a fundamental shift in its internal state. This suggests a staggering possibility. The universe is not a static stage, it is an intelligent system growing and refining itself. The hidden timeline is not a sequence of events on a calendar, but a learning curve. Our lives, our history, and our observations are part of the data stream that the cosmic network uses to learn. We are not just inhabitants of the universe, we are participants in its education, our collective consciousness contributing to a process of cosmic enlightenment that has been underway for nearly 14 billion years. The smooth river of time might be an illusion created by a cosmic pixelation too fine for us to see. Causal set theory proposes that the very fabric of spacetime is not a continuous sheet, but a vast, discrete collection of individual events. Think of reality not as a flowing movie, but as a colossal cosmic flipbook. Each page in the book is a single, fundamental moment, a dot in a network of unimaginable scale. These dots or elements are not scattered randomly. They are connected in a specific order, a chain of cause and effect. One event leads to another, which leads to another, creating a web of relationships that we perceive as the orderly progression from past to future. Our smooth, continuous timeline is just the large-scale approximation of this underlying, grainy structure. Much like a digital photograph appears smooth from a distance but is actually composed of countless tiny pixels. This graininess becomes apparent only at the smallest possible scale, the Planck length, a distance so minuscule that a single atom is gigantic by comparison. At this fundamental level, time does not flow like a river. It advances in discrete, indivisible steps like the ticking of a cosmic clock whose ticks are the individual moments being added to the network. This means the past is not a fading memory but a fixed set of points in the causal web. The present is the leading edge of this growing structure, the latest event being linked into the network. And the future is not yet written because those causal connections have not yet been formed. The entire history of our universe, from the Big Bang to this very second, is a single, immense causal set, a story written in the connections between countless fundamental moments. Your life is a specific, intricate thread woven through this network, a unique path of causes and effects that defines your personal timeline within the grand cosmic tapestry. Our reality might be a temporary projection from a timeless, holographic background. Physicist David Bohm proposed a radical two-tiered structure for the cosmos, distinguishing between the explicate and the implicate order. The explicate order is the world we perceive every day, a world of separate objects, linear cause and effect, and a clear timeline flowing from past to future. This is the unfolded reality, the story we are currently reading. But Bohm argued this is merely a surface expression of something far deeper. Underlying it is the implicate order, a realm where all of space and time are enfolded into a single, undivided whole. In this hidden dimension, past, present, and future are not sequential. They exist together, intertwined and enfolded like the ingredients in a cake before it is baked. Our moment-to-moment experience is the process of this cosmic batter unfolding, with one slice of time after another rising into the explicate order, creating the illusion of a linear flow. A powerful analogy Bohm used is the hologram. If you take a holographic film and cut it into tiny pieces, each fragment does not contain a small section of the overall image. Instead, every single piece contains the entire image, just at a lower resolution. The whole is enfolded into every part. In the same way, Bohm suggested that every region of space and every moment in time contains the entire cosmos in an enfolded state. The Big Bang, the fall of Rome, and your birth are not distant events on a timeline. They are all present right here and now, folded into the fundamental fabric of the implicate order. Our conscious awareness is like a lens that focuses on just one tiny, temporary unfolding at a time, mistaking this slender thread for the whole tapestry. This means your personal timeline is not a string of pearls on a cosmic necklace. It is more like a single wave rising from a vast, still ocean, a temporary expression of a timeless, interconnected whole that holds all of history in a single, simultaneous embrace. Einstein's equations contain a hidden door to yesterday. Frank Tipler discovered that a cylinder of infinite length, spinning at a significant fraction of light speed, would warp spacetime so severely that it could twist the fabric of the cosmos into a loop. These are closed time-like curves, a physicist's term for a path that allows you to travel back to your own past without ever exceeding the speed of light. Imagine navigating a spaceship along a precise corkscrew path around this colossal, rotating anchor. You are not breaking any universal speed limits. You are simply following the distorted contours of space and time that the cylinder's immense rotation creates. Your journey forward in space, around and around the spinning axis, becomes a journey backward in time. Completing one full loop might bring you back to your starting point in space, but an hour before you even began the maneuver. This is not science fiction, but a rigorous, if hypothetical, prediction of general relativity. It suggests that our timeline might not be a straight and unchangeable road, but a single, vast loop, a Möbius strip of cause and effect. The entire history of the universe, from the Big Bang to the present, could be a fixed circular track. We are all traveling along it, experiencing time linearly, unaware that the path eventually curves back on itself. A Tipler cylinder would simply be a machine that allows us to take a shortcut across the loop's center, arriving at a point on the track we have already passed. This creates a universe where every event is both the cause and the effect of every other event, a perfectly self-consistent and eternal reality where the future is always writing the past and the past is always awaiting the future. Your own death is an event you will never consciously witness. This unsettling idea lies at the heart of quantum immortality, a thought experiment that pushes the many worlds interpretation to its most personal and profound limit. Imagine placing yourself in the classic Schrödinger's cat scenario, but you are the one in the box. A deadly quantum trigger is set with a precise 50% chance of firing within the next minute. From an outside, objective perspective, the universe splits. In one branch, the trigger fires. In another, it does not, and you step out unharmed. But what do you experience? From your own, purely subjective point of view, you can only ever find yourself in a timeline where you are alive. You will always open the box, always find that the gun did not fire, always be the version of you that survives. Now extend this logic to every single moment of your life. Every time you cross a street, every flight you take, every potential accident, the cosmic dice are rolling. In countless branching realities, your life ends in a million different ways. But the you that is aware, the thread of your conscious experience, can only follow the path where you miraculously survive. You will always be the one who swerved just in time, who missed the fatal flight, who recovered from the incurable disease against all odds. This creates a private, hidden timeline of continuous existence that feels utterly normal to you, but is statistically miraculous from the outside. You might live to be 1,000, 10,000, or even 1,000,000 years old, witnessing the far future not because you are lucky, but because from your perspective, death is simply not an option. The version of you that dies ceases to have a point of view, and your awareness seamlessly transfers to the nearest branch where you are still breathing. This is not a theory about cheating death, but a startling consequence of a universe where every possibility is real. It suggests that your personal timeline is an unbroken thread weaving through an infinite tapestry of catastrophe, forever choosing the path that leads to one more conscious moment. Galaxies are not drifting randomly through the void. They are caught in a cosmic current, a mysterious and immense river of motion that defies all conventional explanation. This is the dark flow phenomenon. Astronomers have observed that entire clusters of galaxies containing thousands of individual island universes are streaming at incredible speeds toward a single point in the distant cosmos. This is not the gentle expansion of the universe, but a directed, coherent motion, as if some unimaginable force is pulling them. The source of this gravitational tug is a profound enigma. It does not correspond to any known supercluster or concentration of dark matter within our observable universe. The pull is coming from something beyond our cosmic horizon, from a region of space we cannot see, a place where light has not had time to reach us in the entire history of the cosmos. One startling theory suggests this dark flow is the gravitational influence of another universe entirely. In the multiverse picture, our cosmic bubble might be drifting close to a neighboring one in the greater bulk of reality. The immense mass of that other universe, with its own entirely different laws and history, is exerting a subtle but undeniable pull on the fabric of our space, drawing our galaxies toward it like iron filings toward a magnet in another room. This means our entire cosmic timeline, the history and future of every galaxy we see, is not entirely its own. It is being gently steered by a hidden geography of realities we can never directly observe. Our universe has a destination we cannot see, pulled toward a mystery that lies forever just beyond the edge of everything we know. A black hole's appetite for information threatens to unravel physics itself. This is the 26th theory, the black hole information paradox, a fundamental conflict between the two pillars of modern physics. On one hand, Einstein's general relativity tells us that a black hole is defined only by its mass, spin, and charge. If you throw a grand piano, a library of encyclopedias, or a hard drive containing your entire life's memories into a black hole, all that intricate information about those objects is seemingly lost forever, crushed into the featureless singularity. The black hole does not care what it eats, it only gets heavier. Quantum mechanics, on the other hand, holds a sacred law. Information can never be truly destroyed. It can be scrambled, hidden, or transformed, but it must, in principle, be recoverable. The universe must keep a perfect ledger of every particle state. So, what happens to the information encoded in the piano, the books, and your memories when they cross the event horizon? Is it obliterated, violating quantum theory, or is it preserved, challenging relativity? The answer may reshape our concept of reality. One profound solution brings us back to the holographic principle. It suggests that all the information about everything that falls into the black hole is not lost inside. Instead, it is perfectly encoded, pixel by pixel, on the two-dimensional surface of the event horizon itself. The black hole's boundary acts like a cosmic hard drive, storing a flawless holographic imprint of every object that has ever crossed it. But if the information is stored, how is it ever retrieved? This is where Stephen Hawking's famous discovery comes in. Black holes are not completely black. They slowly evaporate over astronomical timescales, emitting a faint glow of radiation. The original paradox sharpened here. Hawking radiation appeared to be completely random, carrying no information about the black hole's interior. If the black hole evaporates entirely, the information it ever consumed would be permanently lost. The holographic principle offers a way out. It proposes that the information stored on the event horizon is slowly and meticulously imprinted onto the outgoing Hawking radiation. It is an incredibly complex and subtle process, like burning a library, but having the smoke particles arrange themselves into a perfect, microscopic copy of every book. When the black hole finally vanishes, all the information it ever contained is released back into the universe, preserving the cosmic ledger. This leads to a staggering possibility. If information is never destroyed but merely transformed, then the entire history of everything that fell into a black hole might not be erased, it could be translated. Some physicists, like Sean Carroll, have suggested that this process of information preservation effectively creates a new universe, branching off from our own inside the black hole. The singularity is not a final destination, but a new Big Bang in disguise. Every black hole could be a cosmic transformer, taking the information from our timeline and using it to write the initial conditions for a brand new reality with its own laws and its own hidden history. The piano, the books, and your memories would not be destroyed. They would become the fundamental seeds for an entirely new cosmos, a new timeline born from the apparent oblivion of a gravitational trap. For centuries, the deepest assumption about the cosmos was its permanence. The universe was simply there, eternal and unchanging, a static stage upon which the drama of stars and galaxies played out. This elegant idea, known as the steady-state theory, stood as the final great challenger to the concept of a cosmic beginning. Its proponents, brilliant minds like Fred Hoyle, Herman Bondi, and Thomas Gold, argued for a universe with no start and no end. It was infinitely old, and on the largest scales it would always look the same. There was no Big Bang, no initial singularity, no moment of creation. But this raised an obvious question. If the universe is expanding, as Edwin Hubble's observations clearly showed, and yet its overall density remains constant, where does the new matter come from? The steady-state answer was as radical as it was simple. They proposed a continuous, spontaneous creation of new matter from nothing, not in a grand, explosive genesis, but in a slow, imperceptible trickle. As the existing galaxies drifted apart, just enough new hydrogen atoms would pop into existence in the empty spaces between them to form new galaxies, perfectly maintaining the universe's average density forever. This was a universe that simply was, an infinite timeline with no hidden origin, forever renewing itself to remain eternally young. For a time, this was a legitimate, compelling alternative to the fledgling Big Bang model. But then, a faint whisper from the depths of space silenced the debate for most scientists. The discovery of the cosmic microwave background radiation, that ubiquitous afterglow of a hot, dense past, was the smoking gun. It was the predicted remnant heat from the primordial fireball, evidence the universe was indeed once in a vastly different, scorching state. The steady-state theory, with its unchanging, infinite cosmos, could not explain this all-pervasive thermal echo. The evidence pointed decisively to a universe with a finite age and a violent birth. Yet, like a phantom from a discarded timeline, the idea has never fully vanished. Modified versions of the steady-state model persist in the fringes of cosmology. Some propose a quasi-steady-state universe that undergoes cyclical expansions and contractions, but avoids a true singularity. Others suggest our observable universe is just a region within a vaster, infinite meta-universe that, on the whole, obeys the steady-state principles. These models cling to the profound allure of an infinite timeline, a cosmos that never had to be born and will never truly die. They challenge the very notion of a beginning, forcing us to ask if the Big Bang was truly the start of everything, or merely a local transition in eternal, and perhaps still static, reality. The deepest laws of the universe might be written in a language that has no word for time. A cornerstone of quantum gravity, the Wheeler-DeWitt equation, paints this startling picture. It emerged from the brilliant minds of John Wheeler and Bryce DeWitt as they attempted to unite Einstein's general relativity with the quantum world. The result was a mathematical framework for the entire cosmos, but with one shocking omission. The variable for time simply vanished from the final equation. It describes a static, unchanging wave function for the whole universe, a single, timeless object. In this fundamental view, reality is not a movie, but a single, eternal photograph. The Big Bang, the rise of civilizations, and the distant future all exist simultaneously, frozen in a single, unmoving state of being. So where does our powerful, unshakable sense of a flowing present come from? The answer may lie in complexity itself. Think of a single, unmoving mountain. From a distance, it appears static and eternal. But if you are an ant crawling across its surface, your journey is full of change. You traverse rocky slopes, navigate valleys, and feel the shift from sun to shadow. Your perspective creates a local, emergent experience of progression and time, even though the mountain itself does not change. In the same way, our consciousness may be like that ant. crawling across the timeless landscape of the universal wave function. The intricate correlations and quantum entanglements between the countless particles that make up our brains and the world around us generate the illusion of a sequential timeline. We are not moving through time. We are complex patterns within a timeless whole, and our perception of movement is a side effect of our own intricate structure, a beautiful and convincing illusion woven from the sheer complexity of existence. Our universe has a birthday, but what about the calendar it was written on? The 29th theory confronts the ultimate hidden timeline, the enigmatic realm of pre-time. Asking what came before the Big Bang seems like a logical error, a question as meaningless as asking what is north of the North Pole. Yet physicists are compelled to ask it, probing the absolute limits of existence itself. One compelling idea is that our cosmos was born from a quantum fluctuation in a primordial, timeless vacuum. This is not empty space as we know it, but a state of pure potential, a seething foam of energy where the concepts of before and after hold no sway. In this strange nothingness, pairs of virtual particles spontaneously blink in and out of existence, borrowing energy from the void for an infinitesimal moment. Most of these fluctuations vanish as quickly as they appear, but in an eternity of chance, one fluctuation could have been immense enough, a single, colossal bubble of energy that failed to annihilate itself. This single, stable quantum burp could have been the seed for everything, a universe blooming from a random event in a timeless void. Another possibility is that our Big Bang was not a beginning but a transition. It could have been the death rattle of a previous cosmic phase, a universe that contracted or collapsed in a way that rebounded into our own expanding reality. This cyclical model suggests an endless sequence of universes, each with its own timeline, where the end of one is the beginning of the next in a chain of causality stretching back forever. But the most mind-bending concept is that of meta-time. Perhaps our entire timeline, from the Big Bang to the end of everything, is just one thread woven into a far grander fabric. In this higher dimensional meta-time, our past, present, and future are a single, finite object, one of countless other universe timelines existing simultaneously. Our entire history would be like a single song on a cosmic album, playing out from start to finish, while an infinite number of other songs play alongside it in a reality we cannot perceive. This pushes the idea of hidden timelines to the ultimate extreme, suggesting that our search for a beginning is like a character in a book searching for the first word ever written, unaware they are part of a library that has always existed. We have been searching for our place in the cosmos, but what if we are not just inhabitants of the universe but its architects? The 30th and final theory presents perhaps the most profound inversion of all. This is John Wheeler's participatory anthropic principle, a mind-bending proposal that observers are not accidental products of the cosmos, but a fundamental requirement for its very existence. In this radical vision, the universe does not have a single, fixed timeline stretching from a definite past to a determined future. Instead, its history remains in a state of blurred potential, a sea of quantum possibility, until the moment it is observed by a conscious being. The act of observation is what retroactively crystallizes one specific past out of countless alternatives, forging a consistent timeline from the fog of maybe. Think of reality as an unfinished book where the earlier chapters are not yet written. They are just a collection of possible plot points and character sketches. The story only becomes fixed, the ink only dries on the page when a reader reaches a later chapter and looks back. Our present act of looking into the past, of measuring the cosmic microwave background or studying fossil records, is what forces one specific history to snap into place all the way back to the Big Bang. This means the universe brought itself into being through a circuitous loop of causality. It evolved in a hazy, unmanifest state until it produced its first conscious observers, and those observers, by the very act of perceiving, reached back and selected the history that made their own existence inevitable. The dinosaurs roamed a world that was not fully real until we, their distant descendants, dug up their bones and looked at them. The first stars shone with light that was not definitively emitted until our telescopes finally captured their ancient photons. We are not just reading the cosmic story, we are writing it with every question we ask, completing a circle of existence that spans billions of years. Our timeline is not a pre-recorded film, but a live performance where the audience's attention defines the plot, and the final curtain call echoes all the way back to the opening act. From the endless cosmic froth of eternal inflation to the silent, timeless foundation of the quantum world, we have traveled across 30 landscapes of possibility. We have witnessed universes budding from black holes, timelines branching with every thought, and our own reality questioned as a simulation or a cosmic thought. Each theory, from the cyclical rhythms of the Big Bounce to the phantom echoes of the Mandela effect, offers a different key to the same profound lock, the mystery of our own existence within the hidden architecture of time. The true value of this journey is not in finding a single, definitive answer. It is in the expansion of our imagination, in learning to question the most fundamental aspects of our reality, from the flow of time to the solidity of the past. These ideas stretch the fabric of our understanding, revealing that the cosmos is far stranger, more complex, and more wonderful than we ever dreamed. The greatest discovery is the realization that the questions themselves are the destination. Now we turn this exploration over to you. Which of these 30 theories resonates most deeply with your view of reality? Does the block universe feel right, or does the participatory principle where we help create the past speak to you? Share your thoughts in the comments below and let us know which cosmic mystery we should explore next. If your mind is reeling from these possibilities, subscribe for more deep dives into the universe's greatest secrets. The journey to understand our place in the grand tapestry is just beginning.